Since we have information about these first couple of terms and these last couple of terms, we want to write the sum of all 100 terms as a function of A1, A3, A98, and A99. So to do that, we'll pull out first the first three terms to keep our A1 and A3, and then we'll continue on from 4 to n. Each subsequent term is going to be the sum of the term that came right before it minus 2 times the term that came before that, and then we add back in the term that came before that. This minus sign suggests a telescoping sum. So let's rewrite all of these subscripts as a sub k. First, we'll separate out each of the terms. We'll factor out the 2 here. When we rewrite these subscripts, we'll have to change the lower and upper bounds of k. Our lower bound of k is 4. For our first term here, this means that we start with a sub 3. Our upper bound on k is k equals n. This is a sub n minus 1. So rewriting, replacing a sub k minus 1 with a sub k, our lower bound is k equals 3 and our upper bound is n minus 1. And we'll repeat that here. When k is equal to 4, our lower bound, a sub k minus 2 is a sub 2. And when k is equal to n, a sub k minus 2 is a sub n minus 2. So we'll rewrite this second term in terms of a sub k, starting with k equals 2 and ending with n minus 2. And we'll repeat this with our third summation. This will make it easier to see what terms cancel out. We'll keep these first 3 terms, and I'll write out the terms in the first summation. This is a sub 3 all the way up to a sub n minus 1. Now I'll subtract just one of these, starting with a sub 2 and going up to a sub n minus 2. Then I'll skip over to this last term. This is a sub 1 up to a sub n minus 3. And then I'll come back and subtract the last one of these from a sub 2 up to a sub n minus 2 again. We'll leave this as it is, and we'll do this subtraction. What we have left over is a minus a sub 2 and a plus a sub n minus 1. Here with these last 2 terms, we have an a sub 1 and an a sub n minus 2. Now we'll combine like terms. The a2's disappear, and we'll plug in n equals 100 to get our sum of the first 100 terms. Recall from the problem statement, we have 2 and 1, and these last 2 terms disappear, and our answer is 3. If you'd like me to solve any other math contest problems, please leave them in the comments.